Hi students, good morning. Now I am going to explain or solve the problems on common base configuration or H parameter model for common base amplifiers. In the previous lecture, the H parameter model for common emitter configuration or common emitter amplifier, how to derive the transistor or how to analyze the transistor characteristic parameters, current gain, voltage gain, input impedance and output impedance from the H parameter model. Now, let us see the problem uh, under common base configuration or common base transistor amplifier. We know that in the circuit diagram for common base configuration, basically keep base is common and emitter is input and the collector is output. So when we connecting any base resistor and source resistor, if you providing the AC input signal Vs, okay, and then it is some like input resistance or the biasing resistor, and it is in series with the source resistance of the source, and then output admittance, output impedance, and connected with the load. So we can take it as Rx and Ry, that is load resistor. We can measure the output voltage. It is a collector, it is base terminal, it is emitter terminal. So if you want to measure this characteristic parameters, we take this the like transistor diagram converted into H parameter model. Once H parameter model, it is very easy to find out that parameter values like input impedance, output impedance, like what is the input impedance over here, and what is output admittance or output impedance over here, like output impedance, input impedance, and what is the voltage gain for this model using this parameter model, and the current gain and voltage gain. If we including the external circuits like this biasing resistor and source resistor, if we including these two, and also here also if we including these two, that are output the the overall output impedance, like if you take this Ri dash, R naught dash, actual R naught is equal to Ry parallel R naught dash, like sorry, actual output impedance is equal to Ry parallel RL, and what is actual input impedance, Ri is equal to basically this one Rs Ri parallel Rs. So and we will get some, by including the source resistance, we will get some different current gain, AIS we can represent it with, and AVS. Anyway, first let us see that what is H parameter, how to find out this problem in a common base amplifier. So we need to convert that diagram into H parameter model. We know that that simple H parameter model for the transistor. Input is like a KVL, output is like KCL, Kirchhoff current law and Kirchhoff voltage law, which followed that one. As it is common base, this terminal is like a base terminal, and this terminal is like a emitter, this terminal is like collector. Then this is input voltage V1, V2. Here we can mention that it is a common base configuration. The input voltage is nothing but VE, output voltage is nothing but VC, input current is nothing but IE, and V, it is like input current IE, and input impedance, input resistance or input impedance, its parameter model HIB and HRB, V like HRB, HRB, VC, and HFE, HFB, IE, and HOB, like that. We can mark. So it is basically how to draw this diagram and all. I explained in the theory class of S parameter model for common base configuration. Now, how to find out this problem? Okay, to solve this problem, consider all these H parameters for the transistor model, and then is there any the problem sometimes given external circuit also. By considering external circuits, we will find out these four parameters: input impedance, output impedance, and current gain, voltage gain. For this problem, I would like to give the data. Okay, the given data is that the given data for this problem, input impedance for common base configuration, common base amplifier, HIB 28 ohms. HIB is equal to 28 ohms. HFB 0.98 minus 0.98. HRB 5 in 10 to the power of minus 4. HOB 0.34 to the power of minus 6. Siemens. And load resistance given RL is equal to, you can take any small RL calculator, is equal to 1200 ohms or 1.2 kilo ohm. Find out the, and source resistance RS is equal to 0 in this case. Find out the AIRI, AV, AI, RI, AV, R naught. So let us see one by one. Let us see one by one. Voltage gain, current gain, first of all we'll take current gain. AI, we know that direct, we use the formulas. AI is equal to minus HFP by 1 plus HOB into RL. So minus HFB is equal to minus 0.98 divided by 1 plus HOB 0.34 into 10 to the power of minus 6 into 1200 load resistor. By simply seeing this equation, in the numerator we'll get 0.98. In the denominator, all this term 0.34 and 10 to the power of minus 6 into 1200, you will get 0.00 something. So it is very negligible when compared with the one. So we will take that, we will neglect that one. When we neglect it, you will get the answer is 0.98. So the current gain is 0.98. Next one, input impedance. Input impedance. The formula for input impedance is this: Ri is equal to HIB plus HRB multiplied by current gain into RL. Why I am choosing this formula? Already in this expression, the second term in terms of current gain, which is already we derived, already we solved first. So on remaining parameters also already given in the given data. HIB is equal to 28 and HRB is equal to 5 and 10 to the power of minus 4. HIB is equal to 0.98. AI is equal to 0.98, sorry, and 1200. When we multiplying all those things like 5 and 10 to the power of minus 4 into 0.98 into 12, when we like 1200 into 10 to the power of minus 4 which is equal to 0.12, and 0.12 into 5 into 0.98, you will get 28 plus 0.588 or 59, approximately 59. So when we add this to 28.59, the important thing here it is remember that in each case, actually the H parameter model, in the H parameter representation of HFB here is equal to current gain in common base configuration. But when we consider the model, so it is AI is equal to minus not only HFB minus HFB by 1 plus HOB into RL. When we consider this each and every the device parameters, approximately we will get 0.98. Actually, the H parameter definition HFB is equal to 0.98 minus 0.98. Now the current gain is equal to 0.98. So here also Ri is equal to HIB. The definition of HIB is input impedance of the transistor model, the device parameter, plus the remaining parameters. These remaining parameters added with this HIB, actually the HIB means input impedance, by considering this H parameter model. So you will get actually the given value is 28. By considering all the device parameter, you will get 28.59. That fraction means that the accurate value of the input impedance by using this H parameter model. Then voltage gain. Voltage gain. AV is equal to current gain. I am using direct formulas like a current gain into RL by RI. All are available now. Current gain 0.98. RL is equal to 1200 divided by 28.5 by 28.59 or 6. You'll get 41. So AB is equal to 41. Now output admittance. Output impedance or admittance. Basically, we know the formula 1 by R naught or Y naught is equal to HOB minus HFB HRB divided by RS plus HI. Or we can take another formula like 1 by R naught is equal to R naught is equal to RS plus HIB divided by delta H, where delta H is equal to HIB HOB minus HRB HFB. So we use this second formula because all H parameters directly given. So we in this case also given. So we can find out anyone. So now I am finding delta H is equal to HIB, input impedance in common base 28, and HOB 0.34 into 10 to the power of minus 6, and the HRB 5 into 10 to the power of 4 minus 4 minus 0.98. You will get approximately 5 into 10 to the power of minus 4. Then R naught is equal to RS plus HIB by delta H. In this case, since RS is equal to 0 in the given data, source resistance assume that it's 0, and then HIB you will get input impedance 28 divided by 5 into 10 to the power of minus 4 and 5.6 into 10 to the power of minus 4, which is equal to 56 kilo ohms. So R naught is equal to 56 kilo ohm. If you write down all the parameters at once, so current gain is equal to 0.98. Current gain is equal to 0.98. Input impedance is equal to 28.59. Voltage gain is equal to 41. Output impedance is equal to 56 kilo ohm. So concluding that the current gain is 0.98. Input impedance is 28 ohms. Okay, and voltage gain 41. When compared with the voltage gain and compare with the resistances. So current gain is approximately equal to 1. For common base configuration, the current gain is unity, approximately equal to 1. So in the common base, the collector current approximately equal to emitter current. So when we take the current gain, the output current IC divided by E approximately equal to 1. And also we can take that in the configuration, the common base configuration, we can take the current gain is equal to alpha. Alpha range is 0.98 to 0.999 or like 0.98 to 99. So this is approximately equal to 1. Whereas in voltage gain, it is a large value. So in the common base configuration, voltage gain is high, current gain is unity, and input resistance is high, output impedance or output resistance is low. Sorry, input resistance is low, output resistance is high. Here it is 28 ohms in the common base configuration. You will get R0 is equal to 56 kilo ohm. So this input impedance is small, output impedance is very large. We can use this kind of parameters used for like the output circuit of the multi-stage amplifier. So when the input impedance is small, it is matched with the output loads. And AV voltage gain is large compared with the current gain. It will be used as a voltage amplifier. So most of the time by using these parameters, we can analyze that where it will be placed in the multi-stage amplifier. So the common base configuration, it will be used at the output stage. And common emitter amplifier, the current gain is large and input impedance is large. Because of input impedance is large, it will be useful for it is useful for amplifier at a middle stage in the multi-stage amplifier. So we can use this common emitter amplifier. So by connecting of more than two common emitter amplifier, we can get the gain of an amplifier. So in this way, we can analyze by taking all the parameters. With the help of H parameter model, we will find out these characteristic parameters of current gain, voltage gain, and input impedance and output impedance. When we comparing, when we see this common emitter, common base, common collector, after analyzing this H parameter model only, we can conclude that which amplifier is used for which application. So common emitter and common base and common collector. So in this way, so when we connected extra source resistance, we are not assumed that any source resistance is 0, then we can consider that RS. When we consider that RS, that input impedance, the final input impedance value changes. So in this case, if you take that in RS is considered the total overall voltage gain, the external voltage gain Vs connected with RS. If you consider RS, already we have find out that input impedance Ri dash or Ri. So what will be the overall voltage gain concluding with the RS and the Vs? So we will get AVS is equal to AV into Ri by Ri plus RS. Similarly, that current gain AIS is equal to AI into that RS by Ri plus RS. So you will get in this way the current gain including with the source resistance. So likewise, we'll find out all these parameters. We'll take this one. If you take this kind of problems from the question bank, or you can take this problem actually take from the electronic devices and circuit by RS Seda, or you can take from the Salivapana for this problems, simple problems for the you people. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.